Hello dear students, welcome to the 8-week online module on digital electronics and its applications, organized by Department of Electronics and Telecommunication, Government Polytechnic Hingoli. So students, in this week we are discussing the assembly language programming using 808. So in previous lecture we have discussed about the first 6 up to 6 addressing modes. Okay, the 7th addressing mode is based index addressing mode. In based index addressing mode, the effective address is computed from the sum of base register and index register and a displacement. So here we are going to use two indices named as here bx, this is first index, and si, this is second index. Now the basic form of this instruction will be like this: move dx comma bx plus si, and the number 0ah is a displacement. So either we can use this signed displacement or not. So here the effective address is calculated with the help of this bx, si and 0ah like this. So first this 8-bit number 0ah is converted into 16-bit unsigned number. So ah can be written as 0a can be written as 0000 and 1010. So this is a 8-bit number. So this is signed number. So the 0 indicates this number is a positive number. So we will append 80 to convert it into the 16-bit unsigned number. So it will become 000AH. Now the effective address is calculated as bx plus si plus 00AH. Okay. So the base address is calculated here with the help of data segment register. So as we are using the bx register, here the data segment register is used as a base address. If we use base pointer register, then the stack segment register, so here instead of base bx, if we use base pointer, then this ds will change to stack segment, and the effective address and base addresses are calculated. So the physical memory address MA is calculated as BA plus EA. Now when we execute this instruction move dx comma bx plus si plus 0ah, so the contents of MA are transferred to the dx, or we can say that the contents of MA memory address are transferred to the DL, and the contents of next memory address are transferred to DH register. We are already having based addressing separately and index addressing separately. So why we require this based index addressing, which is having two indices here? So suppose we are operating on an array. So this is a two-dimensional array. So to operate on this array, we require two indices I and j. I is a row number and j is a column number. So I is equal to 1, j equal to 1, then the first element is selected. So likewise we require two indices. So in such operations we are using this based index addressing mode. Next we will look into the next addressing mode, that is string addressing mode. Now string is a very important data type, because whenever we want to compare some data we use a string, and here the string can be accessed through the string addressing modes. Now this string addressing mode is employed in the string operations to operate a string data. Now here we require effective data and base data also. The effective addresses of source data is stored in the SI register, that is source index register, and effective data effective address of the destination is stored in the DI register, that is destination index register or data index register. Now segment register for calculating base address of source is a data segment register, and that of destination data is extra segment register. So with the help of data segment register and source index register, we will calculate the memory address of source data, and with the help of extra segment register and destination index register, we will calculate the physical address of the destination of the data where the string byte is to be stored. Now see this example, moves byte. So here we can see that instead of move we are using move s. So s is used particularly for string instruction. Moves s byte. Okay, this instruction moves the 1 byte data from source source address to the destination address. So we can calculate the source memory location and destination memory location likewise. So effective address of source is stored in the source index register, and the base address is calculated with the help of data segment register, multiplying by 16. Now the memory address of the source is calculated by adding base address and effective address. Similarly, the destination memory location can be calculated. So here effective address in extra segment, so this E denotes extra segment. So effective address in extra segment is destination index. The base address in the extra segment is calculated with the help of extra segment register value multiplied by 16, and the memory address in the extra segment is calculated by adding the base address value and effective address value in the extra segment. Now here the contents of the memory location MA are copied to the location MAE, means this is source location and this is destination location. So this instruction is going to affect the affected by the DF. DF is a direction flag. So when DF is a 1, then source index is decremented and destination index is also decremented. And if source direction flag is 0, then source index is incremented and destination index is also incremented. So this addressing mode is helpful to operate on a string data type. Now we'll look into the next addressing mode, that is port addressing. So the port addressing mode is used to transfer a data from the port and to the port. So here there are two port addresses: direct input output port addressing and indirect input output port addressing. So in direct port addressing mode, we use to access data from standard input output mapped devices or ports. So here in direct port addressing mode, the 8-bit port address is directly specified in the instruction. So see this example here. In this example, in AL, 09 hex. So here the port address is assigned a value of 09h hex, which is sent over the address line, and the device is selected, and the device value or data that will be transferred to the register AL. Now here the content of port with address 09 is moved to AL register. And in indirect port addressing, the instruction will specify the name of register which holds the port address. In 8086, the 16-bit port address is stored in DX register. So see here, we are using instruction out DX in the square bracket, comma AX. So here the value of DX, that is the 16-bit port address, is stored in the DX register, and this value is transferred over the address. And the port address, here we are using out instruction, therefore the data or operand which is in the AX register, that is a 16-bit register, that will be transferred to the device which is having the port address which is stored in the DX. So the content of AX is moved to the port whose address is specified by the DX register. The next addressing mode is a relative addressing mode. So in relative addressing mode, here the effective address is specified with respect to the instruction pointer. So the effective address of program instruction is specified relative to the instruction pointer IP by an 8-bit signed displacement. So here we can only use 8-bit signed signed displacement here. See the example JZ0AH. So 0A is a signed hex number, so that 8-bit number is converted into 16-bit number by 000AX. So this instruction shows that jump 0. If 0 is there, then jump to this value. So here the instruction pointer value is added by this value, and the program instruction pointer will be directed to this value. So here if zero flag is checked here, if this zero flag is 1, then the effective address will be equal to instruction pointer plus this added value. Now base address, so for instruction the base address is calculated with the help of code segment register, which is multiplied by 16. Now the memory address will be equal to base address plus effective address. So in previously the effective address was only instruction pointer. Now here the effective address is instruction pointer plus some displacement. Here we are using displacement 000AX value. So if 0 flag is 1, then program control jumps to the new address. And if this 0 flag is 0, then next instruction of the program is executed. So suppose the program count IP value is 2000 hex. Now if 0 flag equal to 1, then instruction pointer will be transferred to this next value, that is IP plus 00AH. So that will become 200A hex. And if it is 0, if 0 flag is 0, then instruction pointer will jump to the 2001 hex value, and likewise. The next addressing mode is implied addressing mode. So in some instructions we do not require any operand. So such addressing modes are called as a implied addressing mode. So the instruction itself will specify the data to be operated by the instruction. So here take an example, CLC. So when we execute this instruction CLC, it will clear the carry flag. Sometimes we use instructions like hold, so it will hold the program. So in such instructions, these are nothing but in hold instruction, the instruction pointer will be hold at a particular value and it will not be incremented. So here in this type of addressing mode do not require any operand. So up till now we have discussed all the 12 different addressing modes here, and by using these addressing modes we can access the data which is stored in the memory by these different ways. In the next video series we will be looking into the instruction set of 8086. Thank you.